Okay, everybody, we're going to get underway here. So I got 6:30. We got really close to 100% people attending, so that's great. Let me begin by welcoming you to the Chemistry 1210 course. My name is Dr. Clark. Um, my plan tonight is we're going to do a little bit in terms of learning about each other with some very brief introductions. Then we're going to spend some time looking at aspects of course logistics. As you probably know, we have a lab portion, recitation, lecture, and a homework system. So I want to make sure we're clear on all of those different features. And then I'd say the second half of class, we're going to move on and look at some ideas within chapter 1. So that's my plan. So as far as beginning learning about each other, let me share some information about myself. So I've been at OSU, I did the math, for like 21 years now. I'm initially from the Detroit area. That's where I grew up, did my undergraduate work and my graduate work. When I first came to OSU, I was a postdoctoral researcher, but I've been teaching the general chemistry courses here for about 16 years. Now, even though I've been teaching for about 16 years, last semester was my first time teaching this course online. And I don't know about you all, but online, I learned a lot about how that works logistically, how to optimize the learning. So I'm looking forward to sharing some of those ideas with you. I'm a researcher here in the department, and I'd say for the last, I don't know, 10 years or so, I've been focusing more on chemical education research. As far as my family, my wife's also works at OSU. She's a professor in education. My daughter, pretty close in age to you all, this is her she just graduated last spring from Cincinnati, and she's now a nurse. Now I've been able to meet with some of you, maybe about a dozen or so, in the office hours that I had on Monday and Tuesday. And I always love teaching this particular time slot in the spring for 1210 because, well, to be honest, there's so many interesting characters. A lot of folks might be joining this class for different reasons. Maybe you're an athlete, maybe, who knows, a lot of different reasons for taking this class, and I really enjoy working with you. As far as being an athlete, I was a college athlete. I did fencing, I played tennis, high school, a lot of basketball, stuff like that. And I bring that up because here's a picture of me for what I've been working on pretty much throughout the pandemic. I've been working on my golf swing. Okay, now I won't say it's a good golf swing, but that's how I've been spending my time, because I found that if you take your phone, you can do a really good job of capturing footage for that. So let me share with you my swing. Okay. Now this is in super slow-mo. This is the first time I swung a driver in quite a while. Now, notice the backspin on the ball. I sort of glanced down and noticed it. Now, you do not have to be a golfer to know that when you swing with the driver, it's supposed to go more than a foot and a half. All right. So clearly, I have a lot to work on with my game. If we have any golfers in the group, we should be sharing ideas later on. As you can see, I got a lot of room for improvement. Now, to learn about you, I'm going to use a couple survey questions. Okay. So I've got 4 different questions. First one I'm going to send your way. And so this would be within our polling. First question involves online learning. So what I'd like you to do is respond to this. So based on my experiences last semester, if you compare in-person learning versus online learning, I'm going to send you a polling question on this. So when it comes to this, would you say number 5 is online's much better, 1 is in-person's much better? You could be somewhere in between, or you can say you haven't taken an online course. Take about 5 more seconds. I'm going to end that one. So let me share the results within that one. First of all, great job responding right away within the poll. We're going to do a lot of polls both tonight and going forward, and that's a really helpful way for me to learn what you're thinking about. Um, right now, we're seeing that the majority of folks are either, I would say, in the 1 or 2 camp, favoring in person. Where I am, I'm probably a 3. I see advantages for both. And when I started last semester, I would have been a 1 or a 2. But I'm more optimistic. I think that there's more benefits than I thought. Okay. So I'm going to try to include those within our own course. Second question for you. When it comes to using technology, whether we're online or in person, general chemistry uses a lot of technology. It's for our homework system. It's in terms of accessing the e-text. You submit things in lab and in different ways. We do a lot with technology. And now we're doing even more because we have Zoom meetings. So overall, what is your view on technology? Do you think that it is something that definitely supports your learning? Or do you view it more as a barrier, something that you have to negotiate and manage? Take about 5 more seconds on that. Okay, overall, let me share with them that one. Overall, folks are agreeing that it can be used to support your learning. If you're in the category here of it helps in some ways, but it's a barrier in others, I want to try to support you to remove those barriers. Okay, I know there's a lot of things that you need to negotiate when it comes to technology, a lot of things that you need to learn how to do. Let's see if we can all get on the same page and try to turn it into something that supports your learning. Next thought here, for this particular course, I'm interested in your perception on your prior knowledge. Do you think that your success in this class is going to be more dependent on chemistry knowledge that you already have? Or do you think you're going to be doing more of learning ideas, new ideas? Let me send you this one. Now, as this one comes in, there's no right answer to this, but this gives me some insights as far as uh, what you might perceive your prior knowledge to be for this subject. Take about 5 more seconds. Now, within this one, I'm seeing that the majority of folks either is in this category of about equal of both and then trending towards learning new things. I think that's outstanding. Okay. If you're in a class where you can be learning new things, I think you're in the right spot. Okay. I mean, it's sort of a waste of time if it's all repetition for what you already know. So if you're thinking that this is an opportunity to learn new things, I view that as a positive. Last one in here about this class. Now, compared to other classes you are taking or you've taken recently, how hard do you think course is going to be? Let me send you that. Okay, take about 5 more seconds. Okay. Now within this one, I'm not going to share the results on this. I want to do something else. Okay. I'm curious what is forming your opinion for the difficulty of the course. I mean, we haven't done very much. We've had just a little bit as far as me trying to introduce a few ideas. We've been using Perusal a little bit. We've done a couple survey questions. So I'm really interested about what is informing your responses, whether this is going to be an easy or a difficult class. So next thing I'd like you to do is I'd like you to use the chat function. If you know how to do that, okay? And my top of my screen is a pull down menu. I can access the chat. Where are you getting your insights as far as whether you think this is going to be difficult or easy? It might be from your past experience. Maybe you've heard from somebody. Maybe, I don't know what you're going to say. Tell me in the chat, what is informing your response as far as whether this would be an easy or a difficult class? So as those are coming, streaming in here, let me say outstanding job negotiating this aspect of the technology. Okay. Right now that you are telling me that we can do many features that are going to be able to make this engaging. You're telling me that we can do polling. You're telling me that I can get quick responses for your perspective. You're telling me that you're able to participate and share ideas in the chat. All of these things I think are going to be really productive for us. Okay. Within the chat one here, take about 5, 10 more seconds. If you still have a response to add, please do so. I'm going to revisit these responses because in a way, these 4 questions and what you just shared, it goes a long way to helping me understand who are the students taking this class. Okay. Now, that was my attempt. And like I said, I'm going to revisit that data a little bit to learn about each other. Let's move a little bit now to learn about some aspects of the course logistics. So I've mentioned we've got 4 different components: lab, recitation, lecture, and homework. Let's step through some of these. Okay. Now, if you add questions or comments along the way within the chat, I'll try to get back to them. I'm not necessarily going to interrupt my presentation here, but I will hear you on that. Okay. I'm just going to try to do the best that I can to cover some big picture ideas. So when it comes to the lab, as we think about this for the spring, let me share some information and tell you what I'm trying to take away from it. So first of all, you're going to need a lab manual for the course. That's something that you're going to need to purchase. We have a lab manual that's distinct for each of the different times that we're teaching the course here. So as I look at this information here, what I would take away from this, you're going to need to purchase a lab manual. We can access it through the publisher website. That's what Hayden McNeil is, or through the bookstore. But we're not going to need it ASAP. Okay. We're not going to need it ASAP because our in-person labs are not starting ASAP. So let's keep this in mind that this is a resource that we're going to need to have, but we don't need to get on it right away. Second, when I look at resources, a lab notebook, this is another specific resource that you're going to need to have. Now, it says here that the lab notebook may be a university-owned iPad, which I think many of you have, or you can go old school where it says regular lined or grid notebook. For additional information, you can look at the lab syllabus. Okay, so as a learner here, this is information that I found on the lab syllabus. As many of you have seen for the course, we have on Carmen posted both a lecture syllabus and a lab syllabus. When it comes to the lab notebook, my suggestion for you is please read the details closely that are listed for lab notebook on the lab syllabus. And the reason I say that is when it comes to our labs at OSU, it's a huge undertaking. We need to coordinate and organize the information for many, many different student assignments. When you look on this one where it says lab notebook and it gives you details about what does it mean to submit it properly, we're not trying to make your life difficult. We're trying to make it so that we can coordinate and organize such a large amount of information. So within this detail right here, this is something that I would suggest. I'm trying to be an expert student here. I would suggest looking at this closely within the lab syllabus, the details for the laboratory notebook. Another feature for you within here is whether you have an when you have an in-person lab. So the first in-person lab sessions, if you look on your schedule, you're going to find that you have a 2 hour, almost 3 hour session on your schedule that's listed as being the lab. When do we begin those? We're going to begin those the week of January 25th. Now, in order to keep everybody safe, we take the class as a whole and we're going to split it up into thirds. We need to be socially distanced within that space. So we're going to split it up into 3 groups. Fortunately, OSU has 3 different letters in it. So we're going to designate you as either being in the O group, the S group, or the U group. We don't have those designations set up yet. We're going to let you know around January 20th through the 22nd. We'll let you know which group you're going to be in for these in-person sessions. Now, when it comes to the in-person sessions, for the very first in-person lab that you're in, we are going to make it so you understand what the plan is. Notice for the first in-person lab, you're going to be provided with a procedure, an example, what the laboratory notebook looks like. We are going to make it so that you understand the plan. I know the lab is going to be a new space for you, a new learning experience. So within that very first one, our goal is to make it so you feel comfortable and capable in that spot and you can work safely. Then we're going to take that information and you're going to now be able to apply those same plans in the subsequent labs. This idea that you have a procedure, an example, etc. for the first one, but not for subsequent ones. We know what we're doing. In the very first lab, we're going to set it up so you know what the plan is. And then in subsequent in-person labs, you're going to apply that idea. Now, when it comes to the in-person labs, I mentioned that we want to keep everybody safe. Okay, that includes lower density of students, but it also includes what we're manipulating in the space, what you're picking up, what you're handling. So proper clothing, that's a must. So a few details as far as what proper clothing and proper attire is for the lab. So first of all, you have to have it so that you see that statement, the ankles should be completely covered. So obviously you can't be wearing shorts, okay? You have to be wearing clothing. For me, that includes both my pants and my socks to cover that portion of my body, okay? Lab coats are going to be a resource, and those are purchased at within the chemistry building. It's a good idea to eat before lab because we're not going to have food or drink within the space. And this idea of dressing in layers, the temperature can be fickle within our lab. Could be hot, could be cold. Usually it's more prone to be hot. So dressing in layers gives you some flexibility involved in that. Now, I'm going to ask you with a polling question. This is the same thing that I usually ask with a polling question when we're all in person. I'm going to use the same polling question, but it might play a little differently. What I'd like you to do right now is look at yourself. Okay, right now, given these terms right here, are you ready for lab? Right now. Now, this is a polling question that is multiple select. Select all that apply. At this moment, look at yourself. In what ways are you ready for lab and in what ways are you not ready for lab? Multiple select, let me know. Take about 5 more seconds on that. Okay, sharing results with you on this one. Uh, I think I view it as a positive thing that about 40% of you right now are wearing pajamas. I'm not right now. I wouldn't check that, but I don't know. I find that for some reason I find that comforting. I'm a little distressed with this next one, where a couple of you have indicated that you are wearing right now a lab coat that you purchased in the chemistry building. I like that you're like in the mindset for chemistry, but I'm a little disturbed that that would be something that you'd be wearing right now at this moment. Um, the different details within here, I noticed within the chat. I appreciate the way that you're sharing some ideas within that. Um, this idea of having a lab coat, that's something that we'll be providing details with, um, as far as where you can purchase it and how that's managed. That's absolutely something, if you look within the lab syllabus, where you'll find information on that. As far as finding additional information, I've mentioned that if you look on Carmen for the lab syllabus, I think that is a really good resource for you. It gives you a good overview, and not just an overview, I'd say specific information about the different features of lab. If you look on that, you're going to find contact information for Dr. Moore, the lab supervisor, outstanding resource. It's Dr. Moore is someone that can be reached through email, and that you also see that office hours will be listed. Another thing that I found when I looked within the lab syllabus, this is the breakdown that is given there, where it shows that we're starting out, we're in this first week of January 11th through the 15th. There are no in-person lab activities. If we look within the second week, once again, there's no in-person activities. And then we see this dividing you up in either groups O, S, or U. And that's where we'll be rotating through. So as an expert student, as I'm looking at this, participating in these labs, it's something that we're going to prepare you for as we move ahead, but in a really good way, it's not something that we're working on this particular week. So if I were to think then as far as action items for lab, what I would be doing or thinking about right now, I know that in the future, I'm going to have to purchase a laboratory manual. In the future, I'm going to learn what group I'm in. Based on what group I'm in, then I'm going to see when my lab starts. The first in-person lab here is the week of the 25th. And recall within that one, for the in-person lab, for the very first one, information will be provided such as the procedure, an example of what a laboratory notebook looks like. We work through those first steps, and proper clothing is required. So as I think about those details, there's nothing that you need to do right now pertaining to lab. We're going to work to keep you updated. We're going to work to make it so that you're comfortable and you're ready to go as we move into that. And once again, the lab supervisor, outstanding resource for getting questions answered. But if I could jump ahead, I would say even a better resource, carefully look at the lab syllabus. It's really comprehensive, and it'll address many of your needs. Okay. Now, I want to then spend a little bit of time next talking about other course components. I've noticed within the chat, a lot of you are helping each other as far as giving responses to laboratory questions. I'm going to look a little bit there to see if there's anything else that is important in order to pick up. But I want to move on to another course component, which is our recitation. Recitation, everyone has recitation once a week. On your schedule, it's listed as a 55-minute lab. So if you look at your schedule, you're going to have one lab that's going to be this 2-hour, 55-minute one. That's your one where you would be scheduled to be physically involved with a lab. The second one here, that's, even though it's listed as a lab, that's your recitation. The recitations are led by teaching assistants. The recitations are online. You should have a Zoom link for that. It's probable within your Carmen course, you have Zoom links for more than one recitation. That's just how they just get scheduled within the system. You only have to attend, and I'm going to add, you only have one recitation to attend each week. Which Zoom link should you use? Once again, it's the one that's on your schedule listed as a 55-minute lab. For the first couple weeks here, all of the recitations are going to be online. Beginning week 3, the ones with Rylan Watkins, those are going to take place in person in Denny Hall. Now, within the recitations, the first week, try to attend the recitation. My goal for recitation for the first week is to help you to learn about the course. I know I'm throwing a lot of information at you. Okay, so by learning about the course, I mean learning just about how the logistics are and how all the ideas and everything come together. That's my plan here for the first week. Now, in subsequent weeks, we're going to work on topics that I know students struggle with. I'm going to have us have activities that are attending to things that I think are going to be different topics, different skills that are going to really support your success in this course. Now, with my recitations, I don't have quizzes or anything in those spaces. You're going to get full credit by attending the recitation and participating. Okay. I'm not going to make it any more difficult than that. I want to make it so it's a good learning experience for you, and try to attend beginning this week, and we'll just make it a positive space. When I'm thinking about then lecture, as far as the logistics around that, lecture is going to have a pre-class component, in-class component, and then after class. By pre-class, I mean that I'm going to have a pre-class video assignment posted in Perusall for every class. I'm also going to post slides in Carmen. Now, within the class, I view this as an opportunity for us to share ideas. Using the polling and the chat function, this is going to be a really great way for me to hear from you. And then after class, I'm going to be suggesting problems that you can work from the textbook. There's going to be mastering chemistry homework assignments pertaining to that. And I'm also going to take all of these lectures as they get recorded. I'm going to post them in Perusall as well. So a couple thoughts within this plan for lecture. I know this plan works. This is what I tried last semester, and the students were very successful with it. Now, when I say we must practice our best communication skills, you know, this is not like we're all in person and we're looking at each other the same way. I'm going to do my best to try to present information either through different forms of technology. I'm going to do my best to try to communicate the information with you. And I need you to try your best to be receiving that information. I know this plan works. And that's what I'm going to try to be putting into practice for us. Now, a couple different ideas here that I mentioned. This idea of Perusall and mastering chemistry. Mastering chemistry is our homework system that you access through Carmen. When you get into mastering chemistry, you'll see that it has its own calendar, its own schedule. Perusall is accessed through perusall.com. It also has its own calendar. I'm pointing this out because both of these features, they're not going to show up on your Carmen to-do list. They're both outside of that Carmen schedule. I'm not syncing them with that. So you need to be aware in both cases of assignments that are showing up there. But I think you're going to be able to handle that. Both of those are pertaining to the homework. Now, for both of these resources, when it comes to Carmen and mastering chemistry or Perusall, I've made videos that I've shared with you all to try to get you started on these particular resources. For the one involving Carmen and mastering chemistry, I pointed out that this getting started to-do list is going to be a good way to begin tackling the class. Things like looking at the syllabus, completing the first academic misconduct quiz, taking a lab safety quiz. These are all things that I described within that video. Also asking you to register for the online homework system. That's what Mastering Chemistry is. So Mastering Chemistry is our online homework system. You access that through Carmen. That's also the link to the e-text. Right now, a very large proportion of the students have already done that. When it comes to Perusall, this is another resource that I think is going to be really helpful for us outside of class. So within Perusall, that's where I'm going to be posting pre-class video assignments. These are also something that's going to contribute to your homework grade within the course. Perusall is the best resource that I know of for us to share ideas asynchronously. I think it's extremely important for this class to function. I think we want to be able to share ideas asynchronously in a deep way. And so that's going to be something that, excuse me, that Perusal enables us to do. Now, I'm also going to place the lecture videos in Perusal. These are not going to be graded, but I think that these are going to also be a great way to share ideas. If there's ideas as we go through class that you're unsure of, or you have a question about something, when it's posted in Perusal, that will be a really good way for me to see those questions, respond to it, add more information. It'll allow me to respond to you in a much deeper way than I can if we just have something as with the chat going along. So the way it works, I think I'll probably be able to post information, the videos within Perusal, probably the next day. So attendance in class, it's not required. I think it's beneficial, but either in the in-person synchronous class or the follow-up one within Perusal, I think those are going to be really good ways for us to share ideas. Now, I'm curious within here. I know that I've tried to reach out to people, but we're all getting together on the same page in different ways. So I'm going to send you a poll on this one. I'm curious what you've already done. I'm curious if you've watched the video for Carmen and Mastering Chemistry, if you've completed some of these Carmen getting started tasks, if you're in Mastering Chemistry, if you tried to get in Mastering, but you had some trouble and you're not in yet, if you watched the video for Perusal, enrolled in Perusal, worked on the first assignment. So let me send you a polling question on this one. So this one's going to be select all that apply. In terms of these logistics, what have you done? Take about 5 more seconds for me. Okay, just to share the results here to get so you can get a sense of where you stand relative to your classmates as far as these first and logistical tasks. Here's the information on that. Now, what I'm going to do with this, I'm going to look closely within this data because I want to try to be able to help everybody take care of these logistical tasks. Okay, I want to try to be able to have everyone get up to speed so we're in good place as we begin the semester. So if I reach out to you, or if I'm trying to make it to, for example, if you've had trouble enrolling in Mastering Chemistry and you're not in yet, that's something I want to try to get resolved as soon as possible. Now, I mentioned Mastering Chemistry. Here's the calendar within Mastering Chemistry. This has a schedule of when all of the different homework assignments are due. So let me step you through this one. So right here, we're on what? We're on the 12th. So the way that I've set it up, the first assignment that you're going to have due within Mastering Chemistry is due on Friday. It's an introduction to the program. So if you're not in the program yet, I want to make sure that you're in so that you'll be in a good space to be able to complete that first assignment. I don't have any other homework due within Mastering this week until Friday. We're going to be covering here content within Chapter 1. And I've taken that weekly content and I've made a deadline of Sunday night for that. Then for the week 2, you notice it's set up on Friday and then Sunday night, and then Friday and then Sunday night. I'm trying as much as I can to keep it so your week itself, internal to the week, is open. And I'm also trying to put it in a pattern so you know when the assignments are going to show up. I think it's set up within the system. The default is you will see it on your calendar within Mastering 1 week before it's due. I'm not going to take any assignment and sneak it up on you. This is going to be how I'm going to try to run the initial schedule. The corresponding perusal assignments, those are before class on Tuesday and Thursday. So within this overall breakdown, this is what you should expect for your homework. Perusal assignments before class on Tuesday and Thursday, and then homework assignments pertaining to mastering on Friday and Sunday. You'll be able to work ahead if that suits you, but I want to make it so we have a clear plan that we have throughout here. Now, I've gone through a lot of logistics stuff. I know I've thrown a lot of things at you. We're about 35 minutes in. Let's take a break. Let's take a 5-minute break, okay? I've got right now, time-wise, I've got 7:06, okay? I'm gonna start back here at about 7:10, okay? So take a 4-minute break right here. Get up, stretch, move around. What we're gonna move on to next is looking at ideas from chapter 1.
Professor?
Yep.
I had something that I put in the chat that was that I sure you didn't see because there's a lot of chat things going on right now. Perusal, I actually found it very difficult to do. And it seems like a lot of people are having the same issue because there's this YouTube recommendations thing that comes up anytime you pause it. And when you're trying to like type things or look at the chat that's going on, and it covers half the screen, so you can't really like look at the questions at all. And also it's very difficult to like choose the like little circles for the video.
I know about the first part. What do you mean when you say choose the little circles? Tell me more about that.
It's like there's like a little line where all the little circles are, where everyone has put their comments, and it's actually difficult to try. I'm on an iPad, so it's like with my finger, and it's like if they're like right next to each other, it's really hard to like only choose one.
Yeah. So a quick suggestion within that. So I'm aware of the interface and that aspect of the functionality. When you post a video within it, it has great designers, but currently the designers of the program haven't been able to figure out how to turn off that function. It's something with how when it's posted as a link, you don't need all the details. Long story short is the idea of making it so it's cleaner and it doesn't show that that other information at the bottom, that's currently something that they can't turn off as a default. So the way that I use it then, because I see the same thing that you do, okay? So what I do within it is I'm letting it play as I'm working on it. I'm dropping in, and I usually don't make it so it's, I don't maximize the entire screen. I usually take it and I have it, so it's pulled up on my screen, but I don't make it where I click so it covers the entire screen. So I'm watching it, I'm going through that way. I haven't used an iPad, so I can't exactly say about that particular feature. But one thing that's helpful within it is if you want to, instead of going to a specific circle at the bottom that's designating, what you'll find is on the right-hand side, it has a forward arrow to it. And by clicking on the forward arrow, that steps you through the different features. Let me see if I can pull that up. So what I'm saying is, so same thing that I'm seeing with you, where I might have information here within the bottom, right? And so if I have a particular tab or a particular set of comments here, what I'm talking about are these arrows right here.
Yeah, the problem with being on iPad is that discussion takes like half the screen. And then that YouTube thing covers half that part of the screen, so I can't see the video at all. And if I exit out of it, it resumes the video.
Let let me check in with the designers within it. When you do it, do you keep the do you enter full screen, or are you keeping it more like this?
Uh, I guess I'm in full screen.
Uh-huh. Yeah.
I didn't see an option. I just used it as it was.
Mm-hmm. Let me check in, because like I said, I know that the designer folks are quite responsive. So if I were to summarize, your main thing is that you're challenged when you're trying to both have a video and to have the annotation section. That's difficult on an iPad.
It's really difficult.
Okay. Uh, yeah. Let me see within that. Do you have the ability to access it through a computer or not?
I'm getting a computer soon, so I will in a few
Let,
days.
let me see what I can learn too. Okay.
Hey,
Definitely in
also,
the category of let's see if we can make the technology work better for everybody.
I was gonna say before you closed out of that, if you make the screen slightly less wide,
Hmm.
the screen you're viewing it on, the more videos at the bottom will actually go away.
Really? Okay. Yeah, I haven't messed with
You
that part.
you can't exactly do that on an
Oh
iPad.
yeah, it's only a computer thing,
Mhm.
but it makes it still hard to click the dots at the bottom to select the chat options.
Yeah, I usually, if I'm at the bottom within that, if I click on one, I'm just then clicking on forward. I step through them that way instead of trying to track down an individual one. Uh, let's see what we can learn. You're teaching me a lot, because I haven't actually used it as an interface with an iPad yet. Um, cool. All right. Let's uh, let's see if we can make a little progress here within uh, these ideas within chapter one. Um, so first of all, within here, chapter one, I see a breakdown of the different sections. For each of the ones, for as far as the different sections, I tried to put down what I think the main learning objective is for each of those. So when I'm taking the particular content in the book, that's how I'm trying to break it down. Okay. That's how I'm going to try to help us try to make sense of it. So here's sort of an overview or a summary of how the ideas fit together. And the arrow just shows as far as what I view as a progression through the material. Now, when I look at these ideas right here, as far as how they typically show up on exams, I would look at it in this way, and I'm stacking those up on purpose. I'm stacking them up sort of like as a pyramid, because I know based on historical data, these are typically how students score on these types of questions. So I'm sort of stacking it up where we've got easier things at the bottom and more difficult things at the top. So what I want to try to do is make it so that we can achieve and reach and do well at the ones that are at the top of our pyramid. Now, I've put in thick here a skill that's going to be one that I know we're going to use quite a bit throughout the semester. That's doing things like metric conversions. Something like significant figures and calculations, that's something that we're not going to be using again and again throughout the semester, but it is something important in lab. So what I'm trying to say is within this, I've got a pretty good sense for how the ideas in the chapters show up in different parts of the class. And I'm going to try to use that as I prioritize how we spend our time. Now, in the initial assignment for perusal, I think we are exploring these first ideas of describing matter. We are certainly spending time classifying matter. And if I look at that as far as where that now falls as far as degree of difficulty, classifying matter is actually, I would say, one of the lower scoring ones within this first chapter. So I want to make sure we spend some time on it and we practice it here. So this is a skill that you end up having. Now, I want to within here, if you haven't yet done so, I want to give you a little bit of insight about the e-text. So when I go to Carmen, this is what if I click on my lab and mastering, my page looks like. This is going to be pretty similar to what you have. This is what I use to access the e-text. So when I click on my lab and mastering, it gives me the option then of clicking on the e-text. I'm using Safari here, at least in mine, or excuse me, Firefox, at least with mine, I find that works better. Sometimes mastering is pretty fickle with the browser that you're using. Now within the eText on the left-hand side, there's a menu, so you can pull down what section you want to go to. Now each of these within that, you find that right at the start here, oops, sorry about that. When you're in a particular section, right at the start, it lists what the learning objectives are. So that's a really good way to make sense of your reading, is by looking to see, well, what are the corresponding objectives? I also find that the eText, they've done a really good job of making it interactive in different ways. There's different questions that it prompts you where you can get feedback right away. You can try to answer things where it shows ask a question, shows answers to it. There's worked examples, worked example videos. I think the textbook is a really good resource. Now I see within this one, in this first question here at the start, it's got this section, why study chemistry? Now, as I think back with my own college experience, undergrad, I was a triple major. I was a major in chemistry, history, and religious studies. And I bring that up because every time I took a class that might be a history class, a philosophy class, the instructor always took a little bit of time to describe why that discipline was important. They would describe why philosophy was important or why history was relevant. But they never talked about that in my chemistry class. They never talked about that in my physics class. They never talked about that in my math class. For no science class did the instructor ever say, well, let's pause for a second and consider why this is an important discipline. The science teachers never justified why it was important. And I always found that curious. And, it's changed my perspective a little bit. The authors say that chemistry lies near the heart of many matters of public concern. And, as I think about the world we live in right now, I think I need to work a little bit harder to say why chemistry is important. And when I say that, I mean, if I look around the world right now, science is under attack in a way that it hasn't been in my lifetime. We have fake medicine being promoted. We've got examples of where weather forecasts are being doctored. We've got a pandemic that's ravaging the country. We've got examples in which snowstorms are being said to be evidence that global warming is an expensive hoax. And it's not just in the United States. If we look at France, there's an anti-vaccine movement. If we look within the US, same kind of thing. So my point being is that my entire lifetime, I've never thought it more important to be scientifically literate. That's the world we're living in right now. And I want to make sure that that's a priority for us. Now, where this connects to chemistry, I'm curious. This is not a polling question, but I'm curious if you've ever heard of QAnon. There's a chemistry connection. Now, when it comes to QAnon, it's because, this is the Gallup poll, more and more Americans are becoming aware of QAnon. Opinion is mixed. The majority of the US population thinks it's a very bad thing, but about 40% of Republicans have heard of it, say it's a good thing. So where does this fit chemistry-wise? Let me tell you, okay? So the basic premise of QAnon is that a top government insider, Q, is close to the president, and he has proof that global elite secretly enslave and torture children, extract their blood for a life-extending chemical named adrenochrome. Now, adrenochrome, where did this come from? It comes from a movie. It's from a scene in Fear and Loathing in Las Vegas. That is the inspiration for this life-extending chemical. Now, in real life, it's a synthetic compound. Here's the molecule for it. My point within this, we want to be in real life. In this class, when it comes to chemical ideas, chemistry, let's just stay in real life, okay? There's plenty of science for us to worry about and to be concerned with. We're going to see that science and chemistry has wonderful, strange ideas. We don't need to connect it to a secret cabal of global elites that are trying to enslave and torture children. Chemistry has enough drama in it already. Now, a thought on this when it comes to why I study chemistry, here's a really interesting piece of information, okay? So on this axis, the x-axis here, this is for a given country, how much science does the population know? And the vertical axis is how much do they think they know? So if you're above this line, above the trend line, it means you are overconfident. It means you think you know more science than you actually do. If you're below the line, you're underestimating your proficiency. Fascinating data set within here. Look at the United States. Do citizens in the United States know a lot of science? Yeah, I see them towards the right-hand side. But I also find it remarkable that citizens of the United States are the most confident that they know a lot of science. And that's not necessarily the case. This aspect of scientific literacy, after this class, I want you to be both confident and to know a lot of science. That's my goal. Now, this idea here that let's get started with some ideas within chapter 1. So when I'm looking then with chapter 1, in section 1.2, these are the bullet points that describe what the learning objectives are. We want to categorize matter into different states and to be able to use vocabulary like pure substance, homogeneous mixture, and heterogeneous mixture. So within the pre-class video within Perusall, that's what I tried to introduce to y'all. So a couple things that I want to have as far as features on that. We're going to find that we're very interested in the atoms that are present and then how they're arranged. The atoms that are present, that tells me the composition. But we're going to see it's crucially important for how they're put together, what the structure is. Throughout the semester, both of those are going to be important details for us. Now, when it comes to understanding the atoms that we're interested in, the elements that we're interested in, what I'd like you to do is, I'd like you to know the symbol and the name for the first 30 elements, in addition to these other common ones: bromine, krypton, silver, iodine, xenon, gold, mercury, and lead. Now, I ran quickly through those. That's what I mean when I want you to be able to know the symbol and the name. Now this, when it comes to the periodic table, you're always going to have the periodic table as a resource, but I know that I'm going to assume that we know that particular language. When I say potassium, I'm going to not take the time to say potassium is symbol K and it's number 19 and here it is. I'm sorry, but I'm just going to use the vocabulary. So as far as an initial task when it comes to the periodic table, try to be able to know the symbol and the name and go back and forth between those. Carbon, nitrogen, symbol F, symbol Ne, stuff like that. And with practice, I'm sure you're going to get very proficient at that. Now, when it comes to the periodic table, I had one student, he said, you know, Dr. Clark, you should be 17, 18, 19. I had no idea what he's talking about. But then if you look at the periodic table, how fortunate is that? I'm a chemist, 17, 18, 19, right in order, spells my name. You know, I wish the student was paying attention, but that's pretty clever, okay? So the science nerd in me, that's the closest I can come. But Clark, you know, when I shared this with students last year, what I saw show up in the chat was someone said, grown dad joke. And the response was even worse, chemistry dad joke. And I think that that's true. Now, when it comes to the vocabulary, as was discussed within the Perusall video, we discussed different states of matter and introduces terminology of calling things molecules, compounds, and mixtures. When it comes to our vocabulary, that's what I know is one of the more difficult ideas for the students. So a molecule is we're going to have two or more atoms that are held together in a chemical bond. If we're looking at held together in a bond, but the atoms are different from each other, then we call it a compound. A mixture is when we have two or more different substances, they're mixed together, but they're not chemically bound together to each other. So if I were going to show that symbolically, this distinction between what does it mean when I have a molecule or a compound or a mixture. I would just summarize it like this. At the particle level, I can have an atom all by itself. A molecule is showing two of them bonded together. If I have two of them bonded together, two or more, and I have different types, then we're calling it a compound. That would be the way that I'm trying to represent these. Now, in this example right here, take a second. How would I classify this? Well, I see molecules of one type. I see molecules of another type that happen to be a compound. And I see an assortment of those. I would be calling that a mixture. Now, within our description right here, a task that I had, and I thought people did a really great job within perusal on this, was taking this image right here, applying this language, and trying to include all of these terms to describe what was going on in this picture. Just to give an example right here, this is one that Taylor had submitted. Said H2O, or water, is both a compound and a molecule made up of the elements hydrogen and oxygen. Absolutely agree. It's being shown in 3 different states of matter, identifying a solid, a liquid, and a gas. And goes on to say that seawater is not, however, a pure substance, but rather a mixture, because there are other things there, other minerals and particles distributed in it besides just the H2O. I think that excellent analysis. I agree. I'd say the ocean is indeed a mixture. When we're thinking about salt water, there's no thing that is by definition salt water. It's not simply the H2O and then this L designating it as a liquid. There's other things within that, different dissolved gases, different salt, different fish. There's different things that would be in the ocean. I would say there's also different things that were in the air there. There might be water vapor, but I bet you've got a lot more nitrogen gas and oxygen gas also being found there. Now, when I look at these different ones, the gas, the liquid, and the solid being shown at the particle level, I would describe H2O as a solid with the S, H2O liquid, and H2O gas. They're all the same substance. They're all H2O molecules, but they happen to be in different states of matter. The building block is the same. Its H2O molecule is the same. What is different is how it's being arranged. That would be another way of saying it has the same composition, but a different structure. So I'd like you to try this question right here. It's a matching question. I got 4 different options here. Take a second before I show my answer. Which of these do you think best represents the molecules of a compound, a mixture, molecules of an element, and atoms of an element? Give that a try. As I look at these particle representations, that would be my answer. I think the first one is atoms all by themselves for a particular element. The second one, they're showing that you have an element, and the element that it's bonded to are the same, so they're forming a molecule. C, I have a molecule, but I'd also call it a compound because I have 2 different types. And then the final one, I have a mixture, different substances being present. This format right here of taking particle representations and applying this vocabulary, really common exam question format for this topic. Another exam question format for it. Well, first of all, before I show you another one, let's add another idea for it. So when we're talking about mixtures, we have different substances present. We can describe those as being homogeneous, where they're all mixed together, or heterogeneous, where we see different regions. So within our analysis here, this is another one that was in the pre-class video. I thought really good analysis between the two. There was the question, well, what if the mixture is homogeneous but has an area that's not as well mixed together? How do we do it then? Do we still call it homogeneous? Is it inhomogeneous? How do we get at that? Really, many students had that same insight. I would say that homogeneous and inhomogeneous, they're relative terms. I think the one on the left, I see as being more distinct than the one on the right. I think B here is more homogeneous. Do I still see regions that are different? regions that are the same? I do, but I think it has become more homogeneous when it got stirred up. I also like this comment from Jordan. Said, so even though nothing has changed in this burrito bowl, it became more homogeneous just by mixing it. I think this is a really insightful question. Notice I didn't change the number of substances that were there. I didn't change their type. I just changed how they were arranged. The same number of pieces of corn, the same amount of guacamole. So as far as looking at things that were homogeneous or heterogeneous, I wasn't changing what was there. I was just changing the arrangement. This example here of this prompt of providing your own examples, I thought really good contributions. So Lauren's contribution here is saying that examples of homogeneous mixtures are table salt dissolved in water and gasoline. Excellent example. Gasoline, several students use that. I think that is a really good example. Because gasoline, after all, there's no distinct chemical formula that says this is always gasoline. Gasoline has things like octane in it, heptane in it. There's different hydrocarbons that are found within it. There's a lot of different substances that are together for what we call gasoline. The heterogeneous examples that were given were cereal and blood. Now, as I read this one, I absolutely agree blood is a mixture. I think it does have different components: red blood cells, white blood cells, platelets, etc. I don't know if it's heterogeneous though. You might know more biology than me. To me, I think blood is all mixed together and is pretty homogeneous. So simply because you have different amounts of them, that doesn't make it heterogeneous. Again, you're probably more fluent with biology than I am right now. I would be inclined to say blood would be something that would be rather homogeneous. I like this comment here where an example was this analysis of orange juice. And this description of, well, you can have the orange juice and the pulp in it. And if it's all shaken up, it appears pretty homogeneous. But if it's allowed to settle out to the bottom, then it would be heterogeneous. So the same things are in the container, but it just gets at the arrangement. So I like that as an example too. Now, a question that I posed within that was, and this is actually, I think, a pretty advanced question. This question was looking at different scenarios. This water, ice water, carbonated water, and the air in your room. And the question was, identify which of these are solutions. So in this case, I'm trying to add some information. I don't think this is an easy question. So first of all, take a second, whether you answered this within perusal or not, pause for a second. See if you can recall what you said. And if you didn't get a chance to try this one, what would you say now? Now, as far as then adding some details here, solution is actually a technical term. A specific chemistry term. It refers to a homogeneous mixture. That's our definition for what a solution is. Now, if I add some more information, if I were to describe this water in the cup, I would describe it as H2O liquid. I would also say the air in the room, it's primarily oxygen gas and nitrogen gas. Let me add some more information for us. If I were to chemically describe ice water, I would say I have H2O as a solid and H2O as a liquid. If I were to describe carbonated water, I would say it's the water, H2O liquid, and it would be carbonated gas dissolved in it. That's what this AQ symbol means. Carbonated carbon dioxide dissolved in the water. Nitrogen gas and oxygen gas, the formulas for those, O2 is oxygen gas, N2 is nitrogen gas. So I'm getting a little bit ahead of myself with ideas that we're going to be seeing. But I wanted to choose, I think, these examples that had a lot going on. As far as what would be the best solutions, which would be describing homogeneous mixtures, I'm looking for more than one substance. I'm looking at them all spread out evenly. I think both the carbonated water and the air in the room would be the best examples for those. The H2O, when I have it both as a solid and a liquid, in some ways, that's sort of a trick question. They sure seem different from each other, the water and the ice, But in terms of our description, it's the same substance, just in two different states of matter. So in some ways, that's sort of a chemical way of saying that we have to look carefully at how things are put together at the particle level and what the definitions are. Now, I say we have to look at that carefully. I look back, this was an exam question that we used before. So it says, suppose your breakfast included the following items: hard-boiled egg, piece of ham, black coffee, and ice water. Which of these would best be described as a pure substance? This was another way that I've seen this topic then addressed on an exam. One was, here's a particle level picture, see which one's appropriate. This is taking a scenario and asking you to analyze it. Now, what you're going to find within the e-text, this figure right here, this is a useful way to step through and figure out how to classify something, this flow chart. So if I were to start with a hard-boiled egg, is it matter? Sure. Is it uniform throughout? It is not. Look, I've got different regions for the egg. It's not all exactly the same. It's a heterogeneous mixture. That would be my description for a hard-boiled egg. How about a piece of ham? Look at the flow chart here and see if you can analyze that. Is it matter? Yeah, a piece of ham is matter. Is it uniform throughout? No, I see different regions, different things going on. I'd say piece of ham, heterogeneous mixture. How about black coffee? Is it matter? Sure. Is it uniform throughout? Yeah, it looks uniform throughout. It looks homogeneous. Does it have a variable composition? What does a variable composition mean? Well, let's think back to our coffee. What's in that coffee cup? I think I've got water there. And then I have different elements, different substances from the coffee that were extracted from the coffee beans. I make coffee every morning, right? I pour boiling water over these coffee beans, and it extracts different chemicals from the beans. It extracts caffeine. It extracts different things that give rise to its aroma, give rise to its taste. There's a lot of chemicals that are being extracted there. Now, sometimes when I make it, I may make it where it's a very strong cup of coffee, and other times it's a weaker cup of coffee. In both cases, it's still coffee. My point is, coffee has a variable composition. You can change the proportion of the different parts in that mixture and still have it be coffee. So coffee would best be described as a homogeneous mixture. It leaves us for our best example, if we go down the line here, of our ice water. It's all still the same substance. It's all H2O, even though it's in two different states of matter. As you think about classifying the different examples, I think for real world scenarios, this information within the e-text, I think this is a helpful way to organize that analysis. Now, tell me within the chat right now, I'm curious, what do you think is easier to analyze? If you're asked to apply this vocabulary, if you have a particle level picture, or if you have a word description like a scenario, what do you think is easier if you're trying to apply this vocabulary? Now, most of what I'm seeing within the responses here, I'd say the consensus is, well, give me a picture. Let me look at the particle level representation. At least for me, I agree with you. That's easier for me to manage. Now, within that description for a picture, a figure being shown, I know that if that's the question, the main difficulty students have is whether something is a compound or not. I know that that's the main difficulty, distinguishing whether something is a molecule or a molecule and a compound. So that's the key thing that I would point out when it comes to those kind of representations. Now, let's move on a little bit here and look at some ideas within 1.3. These weren't included in the pre-class video, so let's move on to some new ideas. So within these cases right here, I show 3 different representations for oxygen. O2 as a solid, O2 as a liquid, and O2 as a gas. Notice in each case, we have this O2 molecule. For the gas, it's all spread out. For the solid, it's all put together. The key thing that's changing right here, I'm keeping the same building block, the same molecule. I'm just changing how it's arranged. That's what's corresponding to these physical changes. So take a second right here. In chapter 1, it introduces two different types of energy, both kinetic energy and potential energy. Take a second. Which of these do you think has to do with the position? Is it kinetic energy or potential? When I'm using these terms, these are the same things that you might have seen in a different class, a physics class or some other class. Kinetic energy has to do with the motion. Potential energy, that's the one that has to do with the position. This idea of potential energy, this is going to be a really important idea for us this semester. Now, we might ask, well, what's leading to this potential energy? Is it gravity or is something else leading to the particles of matter being stuck together? In our class right here, crucial for us is going to be what's called the Coulombic interactions. These particular particles, the charges they have as far as whether they're positive or negative and how they're situated, how close together or far apart they are, really important idea for us. This idea that opposite charges attract and like charges repel from each other, this is going to be something that we use again and again throughout the semester. In fact, we have a whole chapter on this. Chapter 5 is all about looking at, I think, potential energy. Very important idea for us. Now, the reason I bring it up right here, let's think about it, first of all, in terms of gravity. So imagine this, first of all, this description. When particles of matter are attracted to each other and they move closer together, I'm going to say the potential energy goes down. Look at this scenario right here. We have a table and there's a book on the table. Gravity is acting on this book. It has the potential to bring it all the way to the ground. If it falls off the table, what happens? It's going to go all the way to the ground and it no longer has gravitational potential energy. The potential energy has gone down. It was a higher potential energy and it's gone down to zero as they've come together. That's what I mean when I say when the particles of matter are attracted to each other and move closer together, potential energy goes down. The book falling off the table, it came down to the earth. Closer together, potential energy went down. Now, this is true if we're talking about gravity, or it's true when we're talking about our Coulombic interaction. So take a second, look at these pictures for me right here. I'm going to send you a polling question on this one. Which state of matter would you say has the highest potential energy? Is it the solid, the liquid, or the gas? Take about 10 more seconds for me. Okay, so first of all, let me congratulate you for being a good test taker, meaning almost no one is choosing the example which is in between. Even though we are split pretty much 50-50, good job being a test taker, meaning, well, it's got to be one of these on the extreme. It's got to be either the solid or the gas. I agree with you. It's got to be either the solid or the gas. Now let's think back what we just saw when we were thinking about our gravity. When the objects were further apart, there was a certain potential energy. And then as they came together, the potential energy went down. The particles of matter had a potential energy, and as they came together, the potential energy decreased. So if I were to look at this one right here, I'd say the particles of matter have come most together, the lowest potential energy. And as the particles of matter have spread out the most, that would be the highest potential energy. As I mentioned, we're going to have a whole chapter where we look more at this idea. I just wanted to get us thinking about these terms: kinetic energy, potential energy. They're going to be applying for the matter that we're interested in as chemists too. It's not simply if you're talking about a physics class and a elephant going down some slope or something. It's relevant for us as well. And I say it's relevant because I mentioned within our video how when we discuss matter, not everything is matter. Okay? Emotions are not matter. And I mentioned within this one that the reason I bring it up is a lot of times people try to ascribe matter as having these emotions. This language that an atom is happy. Well, an atom can't be happy, but we use that language. We see that language a lot. Eddie had this comment. I think that students use phrases like that just for the purpose of memorization because they don't really think that atoms actually experience emotion. Possibly. This is something that I've studied quite a bit as a chemical educator. And I think what it comes down to, in part, we use language like that when we don't have an understanding of aspects like what the potential energy is. When we don't have language involving Coulombic interactions, when we don't consider aspects of the charge and the distance, then we're left with saying atoms are happy or upset or something. So I think within here, by building a solid foundation with this language, I think we're going to be in good stead to be able to describe things scientifically and properly. Now, these are the same images that I just had for O2 as a solid, liquid, and gas. These would be representations if I'm looking at H2O. Solid, liquid, gas. Notice how the position is changing in each example, but I'm still keeping the same building block, the same substance. Those were examples of physical changes. Within a chemical change, something different happens. Within a chemical change, the identity of the substances themselves are changing. It's not just their arrangement. We're changing the substances that are there. Electrolysis, which means sending electricity into water, is an example. You could start out with the H2O molecules, you send electricity in, and now look what's happening at the particle level. You have O2 molecules and H2. The atoms have changed the partners they were with. That's what takes place in a chemical change. A physical change, you're keeping the same molecules present, you're just changing their arrangement. Chemical change, you are changing the atoms, the partners themselves. You're not adding or removing atoms, but you're changing the atoms as far as who their partners are. That's what happens with a chemical change. So I want you to think about it. Let's go to this example here with orange juice, okay? So let's say I have pulp in my orange juice. We've already explored that as a scenario. My wife, she hates pulp in her orange juice. And it's like, well, why? It seems like it's more organic that way. She goes, no, I don't trust them. I think they make normal orange juice, and then at the end of the production line, they just throw in the leftover pulp. Maybe she's right, okay? I don't want to know too much about that. Let's say you are separating the pulp here, okay? So you pour it through filter paper. You find that the orange juice, the juice itself would go down and you'd have the solid pulp remain. Take a second. Do you think that that best describes a chemical change or a physical change? Is the separation of a mixture a chemical change or a physical change? I'm seeing within the response, strong chat response, physical change. I completely agree. Physical change. Remember, within a physical change, we're not changing our partners at the molecular level. We're just separating out the substances. So I completely agree. When we're separating a mixture, we are not involved with a chemical change. We're just seeing a physical change involved with that. Nice job with your analysis on that. So within here, as far as where we're at, where we're going within chapter 1, I'd say that we've covered the first half of it, 1.2, 1.3, and 1.4. What we have as far as coming up next, we're going to be looking more closely at aspects of measurement, how we express those in terms of their uncertainty and analyze the data, and then do some calculations involving dimensional analysis. The difference for these topics at the end versus the topics at the start of the chapter, almost all of the ones at the end here are going to involve numbers. They're almost all going to involve calculations. So a lot of the things that we have in this class, it's a combination of chemistry ideas with numerical ones. Next time, we're going to be practicing numerical ones. I list here a couple questions that are related to what we talked about today. These are the same ones that were in the perusal video. What I'm going to strongly recommend that you do between now and our next visit, use the e-text and read through chapter 1. When you do that, attend to the various learning objectives, and that'll really set you up well for our next conversation. And second, do your best to manage the perusal pre-class assignment that we have for Thursday. And with that, I'll hang around a little bit if you have questions. Outstanding job contributing and participating here, people. I think we're off to a good start.
My Pearson won't work. I've tried to log in about 100 times and it keeps telling me my password's wrong.
Okay, so
Well,
I think within that, I think you've already given it a great effort. Okay, so what I'd like you to do is I got a couple things that I can follow up with to help you out. Send me, if you haven't yet done so, please send me an email. So you can get either go through Carmen or I'm Clark.789. Send me an email and I'm going to send you back some information that I think is going to help you. Most of the people, and you're not alone, most of the people that have had trouble, it's been exactly with what you're experiencing right now. It's because, I mean, there's not a person there who's giving you permission. It's just their algorithm of how it links the username with the password within that. I'm sure it's going to work. Send me though send me an email and I'll send you right back a couple of tips that will be able to help you out.
Okay.
Okay.
Thank you so much.
Sure, my pleasure.
Bye.
So there's no labs this week, or there's still the 55-minute, like are they online like in the syllabus, or is it just nothing for this week?
There's the only lab is the one that's listed for 55 minutes because that's not really a lab. That's your recitation.
Okay.
But as far as the the chemical lab itself, nope, nothing for you to be responsible for there.
Okay. Thank you.
Sure.
Today, I don't know if it's gonna if it was just because it was the first class, but the chat was very busy. How do you want us to ask questions in class?
I think that the chat within that, that's a difficult space to attend to and actually respond to questions within that, both to ask and respond to questions. I think that it's a way to share information, but it's not necessarily the best way to ask a specific question for me. Usually what I found worked best last semester, and I'm still learning about, the online scene. What I found worked best last semester would be if people had the opportunity to hang around after class, and then we could return to and revisit earlier ideas. I found that in this, this virtual setting, it's not a great setting for stopping and attending to questions throughout. Does that make sense?
Yeah. Okay. Yeah.
Yeah. So I think if I were you, I think you have three options. One option is you could decide, well, I'm just going to throw something in the chat and see who responds to it. I don't think that's a great option. Second option is you can wait till the end of class and then I'll be happy to talk to you about it. I think I know that option works. Third option would be when I take the content here and I post it within Perusal, you can ask anything you want within that one. That also works. Okay. I think in real time as class is going on, it's going to be difficult necessarily though to share ideas at that level.
Hi, thank you.
So
Sure.
are you, so will you